Hello and welcome back to another new video, another new session in our continued journey of trying to master geometry. And our today's agenda is going to be congruence and especially congruence of triangles. So once again, the term might sound difficult, but it is a very easy idea. Also a very important idea because this is a result that we'll be using over and over again in our future journeys. So we should try and learn this idea and try and learn this idea well. And remember, once we learn congruence, it is going to work like a tool for us. Just the way in previous sessions we noticed that once we learned that the transversal cutting across a parallel line, the alternate interior angles are equal to each other. We use that as a tool to derive that the sum of the angles in a triangle is 180 degrees, or that the exterior angle of a triangle is equal to the sum of the interior angles on the opposite side. So the approach is going to be the same. We will start with the basic concept, figure out what congruence is, what are the rules of congruence involved, especially talking of triangles, and then we'll try and apply them in a couple of situations, maybe derive more results or try simple problem solving. So just to get started, what is congruence and do you see it in your real life every day? And yes, you do, and a lot of it. For example, I have a marker here and I have a cap, and I can remove this cap and put another cap here and it will fit perfectly, right? That means these two caps are identical to each other. The shape of it, the size of it, the radius of the circle that you will see, the length of the cylinder, everything is going to be equal for these two caps, right? And congruence is another, basically a fancy word for saying identical in shape. So if I talk about these two caps, the circle that you see on top is going to be congruent. That means the circles that you see here are identical to each other. And you see this everywhere, wherever replaceable parts are involved in your life. Things have to be congruent or identical, otherwise they will not fit. So that's one way of thinking about it. Another simpler way of thinking about it is that if you have two shapes given to you, two geometric shapes given to you, if they can superimpose over each other, that means you take one shape, put on top of each other, this shape will cover the earlier shape completely and perfectly, and vice versa. So for example, a very simple example would be your two A4 size papers. I can see that I have two rectangles, and now if I take this and put it on top of it, this is called superimposing, and I see it is exactly equal to the other shape. Or vice versa, I can take this shape and put it on top of this, and again I see the same result, that one shape covers the other shape perfectly. So that is the core idea of congruence. So when you say two shapes are congruent, and even more specifically in our case, we want to say two triangles are congruent to each other. What it means is you can pick up one and put it on top of each other and they will match each other perfectly because they are identical to each other in every possible form. So two shapes can be said to congruent to each other when you can pick up one of them and put it on top of the other and the shapes will cover each other completely, or the superimposition between them is perfect. So it could be in case of squares, a circle covering another circle, and sometimes you might not, just moving the shapes might not do the trick, you might have to go for some rotation also. But even after that step, if one shape fully covers the other shape, you can say the two shapes are congruent to each other. So let's take this journey to triangles now. If I say triangles A, B, C and triangle P, Q, R are congruent to each other, and this is the symbol of congruence, what it means is if you take this triangle and move it and put it on top of triangle PQR, they are going to be identical. The first triangle will cover the second triangle, right? And consequently, one thing that I can notice almost immediately is that the sides are going to be equal to each other. The corresponding sides of these two triangles are going to be equal to each other, because otherwise how would they be identical? So you have AB is equal to PQ, and the order is fairly important, so pay attention to that. We'll come to that why is the order important in a bit, but as of now just follow it. BC is equal to QR and AC is equal to PR. So the moment somebody tells me that the two triangles are congruent, say somebody tells me that the two triangles are congruent, I can very immediately see that the corresponding sides are equal to each other. So that could be my result number 1, and a very easy commonsensical result to understand. So staying with a very similar story, this is triangle A, B, C. But this time I take the copy and I flip it upside down and I say change the names also P, Q, R. So for this case, can I say triangle ABC is congruent to triangle PQR? No, why not? Because this angle corresponds to this angle, or the angle being formed at C corresponds to angle being formed at P. So not only you will have to move this triangle to this triangle, you will also have to rotate it so that the corresponding sides match with each other. So this will not be the case. Say I want to stick to PQR as my starting point, so I say triangle PQR. Now think about it. You want C to correspond with P. So C to correspond with P, you will say similar to, instead of P, you have a C. Now when you move this C here, what is going to happen? This A is coming to this point and B is coming to this point. So instead of Q, you have a B. So you will write B. And instead of R, you have a A. So you will write triangle PQR is congruent to triangle CBA. This time saying triangle ABC is congruent to triangle PQR will not work. So the naming is going to be important, and not just the naming, knowing which side corresponds to which side of this shape is the important idea. So sometimes it will be very straightforward that ABC is equal to PQR, and sometimes you might have to work a little to figure out what matches with what. Just working with the same idea of correspondence, I have two triangles ABC and PQR, and now I tell you that these two are congruent to each other. It should be visible to you also. If I take this triangle and rotate it and put it on top of this triangle, they'll be equal to each other. Not in the figure drawn on the board exactly perhaps, but in the animation part that you will see, that is working exactly. So these two triangles are congruent to each other. Once again, my focus is finding the correspondence point. So I know that B is corresponding to P, and this narrowest of angle is at this point. So A is corresponding to Q. So however I want to write my congruence, and I can start from any direction. So for example, I say I am starting with RQP. You could have also tried PQR and built a similar story for yourself. In fact, you should try that a couple of times. So I want to say triangle RQP is congruent to. So I want to say triangle RQP is congruent to, but what should be the order, right? So I see what corresponds with R, or if R we haven't done that, I know P corresponds with B, so I know the last term is going to be B. I also see that A corresponds to Q, so the second last term is going to be A, and then obviously I'm just left with C. So in this story, my story would be triangle RQP is congruent to triangle CAB. What that means once again is RQ is equal to CA, RQ is equal to CA, QP is equal to AB, QP is equal to AB, and RP is equal to CB. So if you draw this triangle out and move it across, you will see that these three sides are equal to each other. And in the very same story, and it is very obvious to me, I noticed that the corresponding angles are also equal to each other. So angle B is equal to angle P, angle A is equal to angle Q, and angle C is equal to angle R. So now I have a little more information about when I'm talking about congruent triangles. I know that the shapes will cover each other, but in real life I will not have the luxury of taking the shape and covering and putting on top of each other, right? So what other results I can use? If all three sides and all three angles are equal, I can say that the triangles are congruent to each other. Or if somebody tells me that the triangles are congruent to each other, I can definitely say all the corresponding angles are equal and all the corresponding sides are equal. So that could be my starting observation about congruence of triangles.